Okay, so now if we take a look at this objective is taking the derivative of a f of g of x. Okay, so there's a process. Just like we had power rule, just like we had all those rules for trig and logarithms, just like we had product and quotient rule, we have taken the derivative of an f of g of x. Probably the hardest part is to identify what your f of x is and what your g of x is. So when I do my chain rule, it is the derivative of the outside function times by the derivative of the inside function. What you notice is that this inside function here is literally the same. So I don't change this g of x that I put in the middle. You can't even tell what I just did. You don't change that g of x in the middle. So it doesn't turn into the derivative. It only gets multiplied by the derivative in the end. Okay, so what I want to make sure that we know is like, okay, so let's remember what we do with how we find f of g of x. So we find f of g of x by taking my g of x equation and plugging it in for x everywhere we see x in the f of x equation. So that would be 2 times 4x squared minus 5x plus 7. So then I get 8x squared minus 10x plus 14. Okay. And then now if I were to go backwards, I'm looking at, like we did in the last section, I'm looking at pulling out my my g of x. So my g of x in this case is easier to pull out first, which is x plus 2. And then my f of x is the outside shell of the equation, which is 3x squared plus 4x plus 7. So it's as if I went through and I took out these x plus 2s and I replaced them with x. Okay, and that's how I would get my inside and my outside function. Okay, so now if I want to find this derivative, all we have so far is, without chain rule, is to multiply it out, which would be a total like pain in the butt to do all the time. So if I were to multiply this out, I would have to go y is equal to 4x plus 3, 4x plus 3, 4x plus 3. And not all the time would I be able to multiply out, to get rid of the inside-outside function type of thing, the f of g of x. There's sometimes where, like, if I had trig, like, I couldn't multiply it out to simplify it into something that I could take the derivative of it. So that's where chain rule comes into play. In polynomial sense, like, yeah, I could multiply this out. I probably don't want to, like, ever. But let's see, 16x squared, 24x plus 9. And then I'm going to multiply that by 4x plus 3 again. And then when I do that, I get 64x cubed. Let's see, how do I want to do this? Plus 48x squared plus 96x plus 24 and 3, 72x plus 36x plus 27. I guess it would have been easier if I just used the box, because then I could have had, like, everything kind of nice, neat, and organized. It should have been 96x squared. Just double checking my math here. Yeah, now that looks right. So 64x cubed plus 140. My gosh. Sometimes me and arithmetic sideways do not get along. So 144 x squared plus 108x plus 27. And I've done all this arithmetic, and I haven't even taken the derivative yet. So now I would have to go through and find y prime. So I'd have to do 64 times 3, 192 x squared plus 288x plus 108. Not my first choice of ever doing anything. So what we could do is we could apply the chain rule to this instead. So my outside function is actually my x cubed, and my inside function is a 4x plus 3. So if I were to take the derivative using chain rule, I would have 3 times something to the second power, and then it would be, I keep my inside function of 4x plus 3, and then I multiply by the derivative of 4x plus 3, which is 4. So I would have then gotten y prime is equal to 12 times 4x plus 3, the quantity squared. And if I went through and I multiplied this out, 16x squared plus 24x plus 9. And if I go through and I multiply this out, distribute my 12, I would get 192x squared plus 288x plus 108. And those are the same values, but obviously when I found the derivative this way, a lot easier. Okay, so now we find the derivative using what we call the chain rule, inside-outside function. So if I were to look at this, change to a color here. So y prime, I bring down my 6, reduce the exponent by 1 because that is the outside function. The inside function is 3x plus 5, so then I multiply it by the derivative of 3x plus 5, which is 3. So then y prime is 18 times, 3x plus 5 to the 5th power. Again, my outside function is the square root, so y prime would be 1/2 something to the negative 1/2, just kidding, 1/2 power, which is 3x squared minus x plus 1, and I multiply by the derivative of 3x squared minus x plus 1, which is 6x minus 1. And I really can't do anything with that to simplify. Again, here, y prime, outside function is 3, so bring down the 3, reduce the exponent by 1. And then I'd have x squared plus 1 that stays there, and then multiply by the derivative of x squared plus 1, which is 2x. So my y prime would be 6x, x squared plus 1, the quantity squared. All right, so now we got our check for understanding. So what I want you guys to do is go ahead and pause the video. Do this on your own. There is a typo I could see right now. This should have an X there. Go ahead and do the check for understanding, and then unpause the video and see if you get the same answers that I do. And there is another one here, derivative at a point, so we'll do that one as well. Okay, go ahead and pause the video. All right, so now we're back, so let's do this one. So my y prime, I'm going to bring down the 3, reduce the exponent by 1. What's going on the inside is 2x cubed minus x squared plus 6x plus 1. So I did not change the inside there. Then I multiply by the derivative, which is 6x squared minus 2x plus 6. And then that's really all I can do with that. Derivative at a point, so now I'm going to find my derivative. Remember that this is x to the negative first power. So I want y prime is equal to 2, something to the first power, which is my 3x plus 1 over x. And then I multiply by the derivative of the 3x, which is 3, plus this derivative of negative x to the negative second power. And I want the derivative at 1, 16. So I have y prime is 2 times 3x plus 1 over x, and then this is 3 minus 1 over x squared. Now, where I'm at right now, because I'm just trying to, I don't really need to, I want to find the derivative of the point, so I really don't need to simplify this first. I could just plug in 1. So when I plug in 1, y prime of 1 is 2 times 3 times 1 plus 1 over 1, 3 minus 1 over 1 squared. So that's 2. This is 4. So then overall, I get 16. Okay, and that is it for this lesson.